When sizing feeder conductors for large motors, specifically those exceeding 500 horsepower, the National Electrical Code, or NEC, provides guidelines to ensure safe and efficient operation. A key aspect of this process involves determining the appropriate conductor size to handle the motor's full load current. NEC Table 430.250 is often used for this purpose, as it lists the full load currents for various motor horsepower ratings. However, this table typically only extends up to 500 horsepower. Therefore, when dealing with motors larger than 500 horsepower, an alternative approach is necessary to determine the appropriate feeder conductor size. The NEC recognizes this limitation and allows for the use of the motor's nameplate ampere rating in such cases. The motor nameplate provides essential information about the motor's characteristics, including its rated voltage, full load current, and horsepower. The full load current listed on the nameplate represents the current the motor draws when operating at its rated horsepower and voltage under normal operating conditions. To determine the minimum required feeder conductor size for motors larger than 500 horsepower, the NEC requires that the motor's nameplate ampere rating be multiplied by 125%. This 125% factor accounts for the continuous nature of motor loads and provides a safety margin to prevent conductor overheating. The resulting value represents the minimum ampacity, or current carrying capacity, that the feeder conductors must possess. For example, consider an 800 horsepower motor with a nameplate ampere rating of 800 amps. To determine the minimum feeder conductor size, multiply 800 amps by 1.25, which equals 1000 amps. Therefore, the feeder conductors must have an ampacity of at least 1000 amps to adequately supply the motor. It is important to note that this calculation provides the minimum required ampacity. In some cases, it may be necessary to increase the conductor size further to account for factors such as voltage drop, ambient temperature, and conduit fill. Voltage drop refers to the decrease in voltage along the length of the conductor due to the conductor's resistance. Excessive voltage drop can negatively impact motor performance and efficiency. To minimize voltage drop, larger conductors may be required. Ambient temperature refers to the temperature of the surrounding environment. High ambient temperatures can reduce the ampacity of conductors. Therefore, it may be necessary to increase the conductor size to compensate for the effects of high ambient temperatures. Conduit fill refers to the percentage of space occupied by conductors within a conduit. The NEC limits the maximum conduit fill to prevent overheating and damage to the conductors. If the conduit is already heavily filled, it may be necessary to use larger conduits or increase the conductor size to reduce the number of conductors within each conduit. In addition to conductor sizing, other factors must be considered when designing motor feeder circuits. These include overcurrent protection, grounding, and disconnecting means. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting the conductors and motor from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection rating for motor feeder circuits. Grounding is necessary to provide a low impedance path for fault currents, which helps to prevent electrical shock hazards. The NEC specifies the grounding requirements for motor feeder circuits. Disconnecting means are required to provide a way to safely disconnect the motor from the power supply for maintenance or repair purposes. The NEC specifies the requirements for disconnecting means. In summary, when sizing feeder conductors for motors larger than 500 horsepower, the motor's nameplate ampere rating can be used in conjunction with the 125% factor to determine the minimum required conductor ampacity. However, other factors such as voltage drop, ambient temperature, and conduit fill must also be considered. Additionally, overcurrent protection, grounding, and disconnecting means are essential components of a safe and reliable motor feeder circuit. By following the NEC guidelines and considering all relevant factors, electrical engineers and contractors can ensure that motor feeder circuits are properly designed and installed. It's also crucial to consult local electrical codes and regulations, as they may have additional requirements or modifications to the NEC. Always prioritize safety and consult with qualified professionals for complex electrical installations. Using the nameplate ampere rating multiplied by 125% is an acceptable method for determining feeder conductor size for motors exceeding 500 horsepower when Table 430.250 doesn't cover the specific motor size. This approach aligns with the NEC intent to ensure adequate conductor capacity for motor loads. Always refer to the latest edition of the NEC and consult with a qualified electrician or electrical engineer for specific applications and interpretations. Remember that electrical work can be dangerous, and it's crucial to follow all safety precautions and regulations. Firstly, verify the motor's nameplate ampere rating. This is the starting point for your calculation. Secondly, multiply the nameplate ampere rating by 1.25 or 125%. This provides the minimum ampacity for the feeder conductors. Thirdly, select conductors with an ampacity equal to or greater than the calculated value. Consider factors like insulation type, temperature rating, and installation method. Fourthly, check for voltage drop. Ensure the selected conductors will maintain acceptable voltage levels at the motor terminals under full load. Fifthly, consider ambient temperature. Adjust conductor ampacity if the installation environment has high ambient temperatures. Sixthly, factor in conduit fill. Ensure the conductors fit properly within the conduit without exceeding fill limits. Seventhly, select appropriate overcurrent protection. Size circuit breakers or fuses to protect the conductors and motor. Eighthly, ensure proper grounding. Establish a reliable ground connection for the motor and related equipment. Ninthly, install a disconnecting means. Provide a way to safely disconnect power to the motor for maintenance. Tenthly, consult local codes and regulations. Verify compliance with all applicable electrical codes and standards. Electrical installation should always be performed by qualified personnel familiar with electrical codes and safety practices. The NEC provides a comprehensive set of rules and guidelines for electrical installations, including motor feeders. Always refer to the latest edition of the NEC and any applicable local codes for specific requirements. Understanding the NEC requirements for motor feeders is essential for ensuring safe and reliable operation. By following the guidelines outlined in the NEC, you can minimize the risk of electrical hazards and equipment damage. Always prioritize safety and consult with qualified professionals for any electrical work.